Hello everyone, my name is NGUYEN from the Chonnam National University. I'm glad today to present our work, which is leveraging a WaveNet for dynamic listening head modeling from speed. Our objective task is presented by the animation from the right. It's referred to the face-to-face interaction. So the communication between the two or more individuals, typically in the face-to-face setting. So in real-time analysis, it is essential to enhance the emotional comprehension, so we can create the responsive listener reaction. It can be the key to achieve the realistic digital human interaction across the various applications. So here is the overall pipeline responsive listening head generation baseline, introduced by the paper from 2022. So our input is videos of a speaker, including the sequence of frame. They extract into the 3D parameter, consist of identities, texture, lighting, pose, and expression. And for the audio data, using the Python library to extract the MFCC ZCR loudness feature. So the meaningful feature are concat and put into the sequence decoder GM. Here they use the LCM-based architecture in the baseline, and by that way they generalize the sequence of 3D parameter of a listener. And they leverage a neural render p-render as a reference below to finalize, create the final reference listener videos as a reaction to the speaker input. So our paper focus on the sequential decoder GM, as we will discuss later. We use the Vico dataset proposed by the same paper. They collect the many clips from the TV programs, the screen of containing two people, and one of them is speaking while the other listening carefully. The frontal face of the people are clearly visible, and the facial expression is natural and stable. The listener actively responds to the speaker in a dynamic and real-time manner. And the table on the right is the analysis of the data sets in the three attitudes: positive, natural, negative. And total we have nearly 500 clips, in totally 95 minutes duration. So we propose our architects. It is a WaveNet plus LCM as the decoder generation, and we only use the speaker audio as our input. We put into the WaveNet using the autoregressive mechanisms, and after that put into the true LCM layer with the GD motion, the 3D parameter from the first frame, and finally we get the set of 3D parameter of the listener. Concat with the reference frame as the picture from the listener. The p-render can finally generalize the listener videos as the reaction to the speaker audio and input. So we go into detail our WaveNet based model we implemented. For the given time series x from x1 to xt, the figure from the left and the formula show that the WaveNet factorizes its joint probabilities as product of its conditional probabilities. This means that the model learns to predict data point xt based on previous data point x1 to xt minus 1. So the figure on the right and the formula shows the core component of the WaveNet model, which is a dilated causal convolution. This is a technique to preserve the sequential order of the data. For each layer with a dilated causal convolution, filters are applied to the input sequence by skipping a fixed number of steps, and they determine it by the dilation rate. The dilation rate grows exponentially with each subsequent layer, allowing the model to achieve the exponentially larger receptive fields as it goes deeper. as described in the figure. So in addition to the more complex operation, the WaveNet uses gate activation presented in the following equation with the residual block and skip connection. For the objective loss function, we use L2 distance within the hashbowl, including the angle, translation, and expression. They are encompassed in the 3D-MN overall. The head motion interframe change denotes at mu to preserve the coherence of the video motion of the listener. For the evaluation matrix, we compute the accuracy of a generated pose and expression to the ground truth feature by employing the L1 distance, the mid-square error. And for a comprehensive evaluation of the video level performance, we utilize the structural similarities index, the cumulative probability of blur detection, the pitch signal to noise ratio, Gaussian similarities, and the FID metric. We present our results on quantitative metric, and we compare to the random simulation plus provided by the Vico paper. We compare to the LCM-based model of the Vico and the perceptual conversation hash generation. There was a competition that took the first place on 2022 of the competition by Vico. They employ a bidirectional LSTM based and improve the background of the final output videos. So the results show that our model gets the best overall performance on all video level metric. Here we present our visualization result generated by our model. The speaker route truth on the left, the middle is our result, and the right is the listener route truth. So we can see our method can successfully generate the dynamic reaction video clips of the listening head with a reasonable level of quality. Thank you for your attention.